In this video, we're going to talk about the two other measures of central tendency, the median and the mode. Let us start off with the median. The median is the center or the middle value of our dataset. 50% of the dataset falls below it and is usually denoted by ME or MD or X tilde or X curve. There's actually a debate on how the median is actually defined. Let's have this illustration. Let's say that this bar is actually our dataset, and the median is in the middle. Now, the median will be featured later as another measure, but as we can see in the definition, it says that 50% of the dataset falls below the median. So that means this is 50%. Here's where the debate comes in. Some are saying that this is the other 50% and the median is not included. It strictly divides the dataset into two equal halves. However, some are arguing that if that is the case, then is the median not part of the dataset? Now, there are some that argues like this. If we would have, again, another dataset, and this will be our median, the 50% by this definition, since the one below is already 50%, then the median belongs to the upper 50%. So it's like saying that the median is the lowest score among the highest scorers in our dataset. Again, this is something that is debatable. However, in our course, this is what we will follow. In our course, what we will follow is that the median is the data for the median rather 50% of the dataset falls below it, and the median will be considered as the lowest value on the upper half of our dataset. So taking note of our running example, the median that was computed by our Excel is here. It is the value 8. To actually get the median, the usual thing that we do is we arrange the data that we have from lowest to highest and find the middle value. So we can do it. You can do it manually in Excel. You can sort the data and then just find the middle value. But here, since we already have our data analysis have it done for us, then we get the median of 8. To interpret the value 8 in our data, we will use this generic template that around 50% of the sample units have a value less than our median. So applying it in our running example, we can say that around 50% of the phones shut off after less than 8 seconds. So here, another picture is given to us by this description. This is telling us that around half or around 50% of the phones that we've got will shut off less than 8 seconds. So this is another thing that can give us an idea of what is the performance of our data. Let's talk about one characteristic of the median. Here is our data set. And as we can see, if we're going to look at it from the top left corner, going that way, you can see that it's actually arranged from highest to lowest. And here, it's easy to pick out that our median is 8. Now, one important characteristic of the median is that it's not easily affected by extreme scores. What do we mean? For example, we will change this 30 into a bigger number. Let's say 1000. And let's change this number into, let's say, 2. All we will do to correctly arrange the data is to put 2 here, remove that, and 2, remove that also, and we will have 2, 3, 3. And since this is the highest value, I just changed 30 to 1000. But our median is still 8 because other than those changes, nothing else has changed. The order remains the same. So the median is not easily affected by outliers or any extreme scores. This is usually a powerful tool, a powerful measure, especially if we have outliers in our data. So it's more people would usually use the median if they know that there are outliers in their data. Let's check what levels of measurement we can compute for our median. So again, we have nationality, football poll, IQ scores, and weight. And as you remember, nationality is nominal, football poll is ordinal, IQ score is interval, and weight is ratio. So pause the video and think, from which of these is median a valuable measure of central tendency? Let's see if your thoughts are correct. Does it make sense if we're going to get the median for nationality? The answer is no, because we cannot arrange from highest to lowest nationality. For football poll, does it make sense? The answer is yes, because ordinal data can already be arranged. Does it make sense for IQ score? The answer is yes also, because interval data can be arranged. Does it make sense for weight, which is ratio data? The answer is also yes. As long as our data can be arranged, then we can compute for our median. Hence, since it's only nominal data wherein we cannot arrange our data from highest to lowest, we cannot compute the median for nominal data. Otherwise, for ordinal, interval, and ratio data, we can compute our median. The next and the easiest measure of central tendency to understand and to compute is the mode. This is the most frequently occurring value denoted by MO or X hat. So here in our dataset, we can see that we have actually 2 most occurring values, which are 5 and 11. That's why we would have 2 modes. And we would call this a bimodal dataset. Bi meaning 2, modal mode. So we have 2 modes or we have bimodal. We are bimodal in the dataset. However, one question can be raised here. Take a look at our data table. Excel reports that only 5 is our mode. But as you've seen a while ago in our dataset, if you're going to check it completely, we have 2 modes. 5 rather, sorry. Let us erase that. We have 5 and another mode to be 11 actually. Take note, the reason why only 5 is reported is that Excel reports only the mode that has the smallest, let's write it in capital letters, the smallest value. Which would mean that this is something that we have to double check whenever we're going to look for mode in our distribution, because there might be one mode. Now, again, a while ago we see that if we have 2 modes, we call it a bimodal distribution. If there is only one mode, we call it a unimodal distribution. And if there is more than already 2 modes, we call it a multimodal distribution. To give an interpretation for our mode, we can use the template most or most of, depending on the grammatical structure of the sample units, have a value of the mode. So in our running example, most phones shut off after 5 seconds or 11 seconds. We can also indicate the number of phones or the number of sample units that is being described in this way. We can say that most phones, highlighted there is the number 8 because there are 4 phones that shut off after 5 seconds and 4 phones that shut off after 11 seconds. So combining the two modes, we'll have 8 phones. So most phones, which is actually 8 phones, shut off after 5 seconds or 11 seconds. Now let's take a look at mode and measurement scales. Can we find the mode for nominal, ordinal, interval, and ratio data? Let's see if what your answers or what your thoughts would be correct. Can we find mode for nominal data? The most frequently occurring nationality? The answer is yes, you can. Can we do that also for football poll? The answer is yes as well. Can we find the most occurring IQ score? The answer is yes. And can we find the most occurring weight? The answer is yes as well. Since we are only counting the frequency of that specific score, whether or not it's just a value or a category, or it actually can be something of interval or ratio, we can find which one occurs the most. That's why mode can be computed for all levels of measurement. As implied with this one, mode can be used in any level of measurement. However, mode is also seen as the weakest measure of central tendency. This is because we're only getting the most frequently occurring score. That means we cannot do any more higher statistical computation or actually any higher computation or operation other than just merely counting the highest occurring score. We have now talked about the different measures of central tendency, the mean, the median, and the mode. However, these three are not enough to describe our data. Let's look at why in the next video.